Let's take a look at how to add your tools and tool holders into the Bobcat system. To do this, come here to CAM Part from within the software and then click the plus symbol. Underneath this you'll find milling tools as well as turning tools. Here we're going to add some milling tools, so right click on milling tools and you'll see the option for tools, tool crib, and holders. These are the items that we're going to look at. When adding tools to Bobcat, you can add them on the fly as you go, or come in and configure them before using the system. It's recommended that you do go in and at least add one or two tools before you start so that you know how they work. Let's go ahead and add a tool. So we'll left click on Tools, and we'll see this is our tool library or tool database. In this left hand column are the different types of tools that are available. Let's add an end mill. So here we have end mill rough and end mill finish. Within the operation, two tools are always called for milling, end mill rough and end mill finish. You can use the same tool for both, and you may want to add your tool sizes that you'll use for roughing and finishing under both categories here. If you've owned previous versions of Bobcat and have set up your tools, you could use the Import from File option and locate your tooling file and import it into this version. You can also select tools from here and use Modify or Delete. Let's go ahead and just add a new tool as an end mill rough. So we'll click Add, and this asks us some information about the tool. Its overall diameter. Let's say we're going to use a 3-inch cutter for fly cutting. Our flute length, our corner radius, if any, and the number of flutes that are on the tool. Our overall length of tool and its protrusion length. The number of flutes and the tool diameter are used in calculating feeds and speeds. The overall length and protrusion length are simply used within the simulation. So if you don't have these exact numbers for the overall length and protrusion length, or length of tool sticking out of the arbor or holder, just put a nominal number in. If you do have that information, the simulation will be a little bit more accurate. You can also enter here your tool number. This would be the number that's in the tool changer on the CNC. Different people set these up in different manners, depending. If you have a tool changer or tool crib that you use on the machine where the tool numbers are always assigned to a specific number, then the tool number will be important to you. Some shops set up the tools every time that they set up a job and just set them in numerically or in sequence. When posting a program later on, you'll be able to override the tool numbers accordingly or use the numbers that you've set here in the database. Now, the tool label is the tool description. We're going to call this a 3-inch fly cutter. And let's call it a insert cutter. It's recommended that you describe your tools well in here. Now, these tools, if you're going to add in a custom tool, use a tool that's not in this list or supported by Bobcat, typically you'd enter them under end mill rough or end mill finish, and then just simply use the tool label to call out any custom information about that tool. Do keep in mind that if you're adding an unsupported tool, while you can use it in the features, you'll have to keep in mind for the offsets, and it's always a good idea to use the largest or overall diameter so that you can work with your cutter compensation. You also have a choice of tool material, whether it's high-speed steel, carbide, an insert, or a custom material. This will also help the feed rates calculate properly. The feeds and speeds allow you to either use the system feeds and speeds, which we'll take a look at the setting up the material files a little later, or to manually lock the tool into a particular or certain feed rate. If you have a tool that you need to lock into a certain feed rate, you do so here. Most commonly, you'd set it to use the system feeds and speeds, and these can always be overridden at the job level. We'll go ahead and click OK, and this has now created our 3-inch fly insert cutter with all of the information that we've provided. We'll go ahead and click OK. Now, let's go ahead and add an arbor to that tool. We'll right-click Milling Tools and go to Holders. In here, you'll see that there's some default tool holders and arbors. You can also add your own or create custom ones. Let's add one. We'll call this Standard Arbor. And you could see here there's a drawing. Now this builds the actual drawing of the arbor. This is used for simulation purpose for up to 3.5 axis or 4th axis indexing and rotating cutting. So in that scenario, there's no real gouge checking, so this is not critical. However, it will help improve the performance of your simulation. Let's take this cylinder and give it a height of 1/2 inch and a diameter of 2 inches. And we'll add an additional cylinder, and we'll give it another height of 3/4 inch by 1/2 inch. Actually, let's go ahead and go 1.75. You can see the drawing updates dynamically, so you can actually have your tool holders set up in here per exactly how your tools are set up. Again, it'll just increase the simulation quality. So let's add a cone. So we're going to add a taper. And let's make the top diameter 1.5 inches and the bottom diameter 1/2 inch. You can also add chamfers and fillets to the drawing. Now, if you do this, this will affect the performance. The more that you add for simulation to think about or do or check will affect the performance of the system. So if you don't have a very good or newer, stronger computer, you may not want to add your fillets and chamfers. It's just more that the software will have to render as it's simulating. We'll go ahead and choose OK. And now I've created a standard arbor. You can also create custom tool holders. And let's say we make this 3x2. And we'll put a bottom chamfer of 1/2 inch. And we'll choose OK. Now we can see that we've added a standard holder. And now we can work with that holder and add our own arbor to it. So these tools, you'll see that they load. We have Cat 40, Cat 50, BT 40. So you get most of the standards in here. In the case that you have something custom, you can create your own. So you have this top piece, which is the part that holds the cone, which is your holder. And then your arbor is the actual piece that holds the tool. When you add these, you can assign them to your tools. So we just come back to the tool library by right-clicking on Milling Tools and then going to Tools. And then go Modify our tool. So we clicked on our 3-inch fly insert cutter, then click Modify. And we can assign a tool holder to it. I can choose that standard arbor, and that will include the arbor that we had set up for the simulation. Let's look at tool cribs. When we right-click Milling Tools, we get Tool Crib. Now, what a tool crib is a set of tools that's associated with the file, the parts that you're programming. Tool cribs can be used if you have certain setups for your machine or certain tools in the machine that are pre-set up. So it's pretty much just a grouping of tools. Let's go ahead and add a few tools. So we'll add from our tool library. We were on Reamer. Let's go ahead and choose our Mill Rough. And let's add from our tool library, and we'll add the 3-inch fly cutter that we've made. Choose OK. And let's go ahead and add some drills. We'll come to Drill, add from tool library. And let's say we also have a 1/2-inch drill. So this will just set up the tools that are available within the job to you. Now, as you're programming, you can add tools on the fly. This is something that you may want to come in and set up, add in a few tools so that they're available. And as you're just starting, don't worry about the tool cribs and the holders so much until you get a little bit more experienced with the system. So come into Tools when you first get started. Add a few of the tools that you're going to be using. You'll see later as this progresses that you'll be able to call them up in your jobs and get a better understanding of how they work. Once you've done that and programmed a few parts, you may find it useful to go in and set up your arbors for simulation and to also create tool cribs, which will allow you to bring in sets of tools later on in the job.